Hey guys, today we are going to compute with scientific notation. So we've been talking about how to write in scientific notation, how to use our property rules to help us when we're multiplying, dividing bases that are the same with exponents. Now we're going to combine all of that together and compute. All that means is we're going to add them, subtract them, multiply them, and divide them. So our I can statement is I can compute with scientific notation, choose appropriate units for real-world quantities, and convert values in scientific notation from one unit to another. So as you notice, this is an apply and practice, so there's no build understanding or the step it out is our applying it and practicing it. As we go through this, the check understanding, I feel as we're going to use that as a way to practice. So if you get to the point where you feel like you're understanding this and you want to try it without me, go ahead, pause the video, give it a try, and then see how you did compared to what happens in the video, if that makes sense. All right, so step it out question 1. You can add and subtract with scientific notation to analyze the data in the table. So they give us the national park visitors in 2016. They give us 3 parks and with their number of visitors written in scientific notation. So how many more people visited the Grand Canyon National Park than Yellowstone National Park? So the words how many more, that means to subtract. So we're going to subtract. So how many more means to subtract. To add or subtract with scientific notation, first express the quantities with the same power of 10. These data have the same power of 10. So what they're saying is, since we're subtracting the Grand Canyon and the Yellowstone, if we look at these two, their exponents are the same, so they have the same power of 10, so we're able to easily subtract them. So what we're going to do is subtract their first factors. So what it means by the first factors is the first part of your powers of 10. If we look back at this one, it's just those first 2 numbers right there we're subtracting. So they started it for us, 5.97 minus 4.26, and so we are going to use our calculator to figure out what that is. 5.27 minus, let me see if I can get that, there we go. Thought I had that locked already. 4.26 gives us 1.01. That is not right. What did I type wrong? 5.97 minus 4.26, 1.71. All right. We're off to a great start today. So now that we have that, and we know that their powers of 10 are the same, we don't need to do anything with the powers of 10. So right here we have 1.71 times 10 to the 6th power. Or how many more people? So they just want us to move the decimal. All right, so remember, we move our decimal the number of times the exponent is. So I'm going to come over here to the side so I have a little room. So I need to move my decimal 6 places. So 1, 2, 3, 4, 5, 6, and I add in my zeros to the missing part. So I have 171 with 4 zeros, and that gives me, sorry, Miss Gill is a little off today. Why is that? All right, so that gives me 1,710,000. That is between those 2 zeros. I tried to erase it. It didn't work out very well. Okay, so that one wasn't too bad. The reason it worked out so great is because the exponents were the same. However, if you have one where the exponent is not the same, you have to make it have the same if you're adding or subtracting. All right, multiplying and dividing, we learned rules with those. But if you are adding or subtracting, we're going to have to make this one have the same as the rest. And so that's what they talk about in this part B. I personally feel that they made it way too wordy and made it way too complicated the way that they wrote it out. So I'm going to kind of show you a different way. All right, so it says, what was the total number of visitors to the Great Smoky Mountains and the Grand Canyon? So total means add, right? So in this situation, we're adding. So it says, since numbers are written in different powers of 10, we need to rewrite one number so they have the same power of 10. To do this, first multiply the factor, blah, 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 blah. Okay, so this to me is the confusing part. Maybe it works out for you. For me personally, I feel like it's way too much extraness. So if you joined my live lesson on Monday morning, we talked about ways to rewrite numbers in scientific notation that already appeared to be that way. And so one of the things we talked about is if you move your exponent, we talked about if you move your exponent to the left, you're adding to your exponents. If you move your exponent to the right, you're subtracting your exponents. All right, and so essentially what they're telling you to do in this part is that idea. And so instead of going through this whole multiplying and adding exponents and subtracting them and all that craziness, I just want to show you what I mean by this right here. So if we want to make this a 6 to be like all the other ones, we simply need to subtract 1 because 7 minus 1 gives us 6. So if we're going to subtract, that means I need to move my decimal to the right. However many I need to subtract, so just 1. So if I move that one to the right, then that's going to give me 11.3, and I'm just simply going to subtract my exponent, and now I have to the 6th power. This is the first time since I've taught this, and the many times I've taught it, this is the first time I've seen them do it this way, and I feel that it can be confusing. Simpler said is you're just adding or subtracting exponents. So I'm going to work it out this way. If you need to see more examples done this way, let me know. I can help you with that. It's just, to me, it can get a little tedious, like taking way too long. All right, so now it says, now that we have them in the same power, now we can add their exponent or their first factors. So the first factors was, now we've changed this one. So now this one is 11.3. The other one for the Grand Canyon, if you look back at the top, is 5.97. And so I just got that number from this part right here in the box at the top. All right, so now we add them. Get my little calculator out. 11.3 plus 5.97. If you add them longhand, remember you just line their decimals up, and you get 17.27. All right, so express the sum with the same power of 10. So we have 17.27 times 10 to the 6th power. However, those of you that joined me Monday morning, we talked about how this technically is not scientific notation. You can only have one digit in front of the decimal. So it says, to write your answer in scientific notation, determine how to write the first factor as a number between 1 and 10. In this case, divide 17.27 by 10 to keep the same value. Multiply 10 to the 6th by 10 to get 10 to the 7th. That's a lot of legwork. All right, so simply, or in simpler words, in my opinion, if we need to move this one place to the left, if I move to the left, I am adding, so I add 1. So move to the left, I add 1. I suggest you make it through this lesson, you have this handy, because even I have to reference it sometimes. All right, so now we have 10 to the 7th power, and we have 1.727 as our factor. So we're just moving the decimal to make it in proper scientific notation. Okay, I hope I didn't confuse you with this extra stuff that they put in. You're welcome to try it that way, but it can be slightly confusing. All right, let's move on. And if you have questions on how to rewrite this way, just reach out to me. We can do some practice on that. Okay, Mammoth Cave National Park in Kentucky is known for its limestone stalactites. Stalactite. All right, yeah, I have no idea. That word's got me. So let's just move on. Which form very slowly. About how much does a stalactite grow in 500 years? Oh man. Yeah, I'm not sure how to say that word. I'm sorry, guys. All right, so express 500 years in scientific notation. So remember, we need to have the decimals where it's behind the 5. So that means we moved it 2 places. So we have 5 times 10, and it's a positive exponent because this is a number greater than 1. All right, multiply to find the total amount of growth in 500 years. So they give us this one, 3.3 times 10 to the negative 4th, because it says that that's their rate per year. All right, and so now we're going to multiply it to the 500 years to find out how much growth. So since we are multiplying, we don't have to do the craziness we had to do on the previous one, because we know that the product property, we're allowed to add our exponents. So we're going to use the product property, and we get to add our exponents. And so it makes it a little easier. Adding and subtracting in scientific notation to me is harder than multiplying and dividing. All right, so now we're doing the same thing we did before. What they're doing is we're just combining these first 2 factors together. So 3.3 times 5. And then we're combining the next 2 together, which is our 10 to the negative 4th and 10 squared. So we're putting those 2 together. So we have 10 to the negative 4th and we have 10 squared. So remember, here we just need to add our exponents. So if we put in our calculator 3.3 times 5, we get 16.5. So now we have 16.5. Negative 4 plus 2 is negative 2. So 10 to the negative 2. However, this is not in proper scientific notation. We should have a decimal between the 1 and the 6, not the 6 and the 5. So we're going to rewrite this one down here, 16.5 times 10 to the negative 2nd. So it says rewrite the product so that the first factor is greater than or equal to 1 but less than 10. So we need to move our decimal 1 place to the left. So if we move to the left, remember we add. So we move to the left, we add an exponent. All right, so then we end up with 1.65 times 10 to the negative 1 power. Express the appropriate amount of growth in 500 years in scientific notation and in standard form. So in scientific notation, it would be 1.65 times 10 to the negative 1st. And that would be feet. And then in standard form, remember, if our exponent is a negative, that means our number is less than 1. So we need to move our decimal point 1 place to the left. And so we would have 0.165 feet. All right, so this one we just had to write in scientific notation and in standard form. All right, in part B, which property of multiplication allows you to change the order of the factors, and which property allows you to regroup the factors so that you can multiply the first factors together and multiply the powers of 10 together. So this goes back to 6th grade, learning your property. All right, so the community property of multiplication lets you change the order of the factors, and the associative property of multiplication allows you to regroup the factors. So you just have to remember back from 6th grade the rules. The community property, you can change the order in which you add or multiply. It's not going to change your product or sum or product. The associative property, you can regroup based on what's going on. So like the parentheses. All right, in part B, what property of exponents make it easy to multiply the powers of 10? So this is what we've just recently learned. All right, so the product of powers property makes it easy to multiply the powers of 10 because it says that you only need to add the exponents. So this was just given an explanation of what it was that we did. And the table shows the areas of 3 national parks. Find the total of the parks. Write the total area using scientific notation and a more appropriate unit of measure. Part A says write the area of Everglades National Park in scientific notation. So remember, we need to have our decimal behind the first non-zero number. So we need to move it to where it's between the 6 and the 1. So we would have to move it 3, 6, 9 times. So that's going to be our exponent. So we have 6.1 times 10 to the 9th power. So part B says many calculators have a key labeled EE or 10 to the X that allows you to enter values in scientific notation. The display may look like scientific notation with the X replaced with an E. Use a calculator to add the 3 areas. Write the sum as it appears on your calculator, then write it in. Okay, so if you have this type of calculator, you see the EE button here. If you have a different type for this type of question, you can always reach out to me. We can look at it together, figure out what it is. They gave you a couple examples here, but I'm always more than willing to help you find it as well. If there is a question like this on your own, you can always reach out to me. I'll help you answer that one if you don't have a calculator that works like this for you. All right, so what it's saying is we're going to take these 3 and add them in. Remember, we did rewrite this one as 6.1 times 10 to the 9th power. Okay, and so what you do is you start with the first factors. So we have 1.4. I don't know how great you're being able to see my calculator. All right, so 1.4, and then we're going to hit that EE button. All right, so right here on this calculator, EE, and it pops up with the exponent there. So then you just type in the exponent. So in this case, it's 10. All right, remember, we're adding these together. So then hit the plus sign. Then we're going to do 6.1, the EE button, and to the 9th power, plus 4.1, the EE button, to the 9th power, hit equal, and we get 2.42 exponent 10. So we get 2.42 exponent 10. And so then if we want to write it in scientific notation, remember that's just your power of 10. So you have 2.42 times 10 to the 10th power. Okay, sorry, I have a lot of distractions today. Okay, let's lock that. You found the total area for the 3 national parks in square meters. Square kilometers is a more appropriate unit for a large area. There are 1,000 or 10 to the 3rd meters in a kilometer. So there are 10 to the 3rd times 10 to the 3rd, which equals 10 to the 6th square meters in 1 square kilometer. Divide the results from part B by 10 to the 6th to express the total area in kilometers. All right, so they want us to take what we got in part B, so the 2.42 times 10 to the 10th power, and we're going to divide that by 10 to the 6th. So we're not dividing the factor by anything. We still have that factor. However, remember, when you divide your powers of 10, so we got these powers of 10, remember you subtract your exponent. So quotient rule, quotient, subtract. All right, so you subtract the exponents. So then that gives us 10 minus 6, which is 4, so 10 to the 4th power. So the total area of the national parks is 2.42 times 10 to the 4th power square kilometers. All right, so now we're going to move on to the check understanding. However, I don't feel that there were very many examples in here that everyone would be prepared for the check understanding. So what I do want you to do is you can grab a sheet of paper, and I want you to give it a try. So let me get this moved up. Okay, so if you feel that you may be comfortable, you can go ahead and pause the video right now and give it a try. However, I am going to work them all out. So if you don't feel that you're comfortable just yet, you can follow along here. You can always try on your own. You can pause each one and try each one, see how far you get. That would be an option as well. So because my space is limited on here, I am going to work it out on a sheet of notebook paper. But before we get started, let's read the first question. It says, one library has 4.1 times 10 to the 5th books. A second library has 6,200,000 books. Find the total number of books at the two libraries using scientific notation. So remember, total means we're going to add. All right. We need to rewrite this in scientific notation. So we know it's going to be 6.2 times 10 to the, we got to go 3, 6, so 10 to the 6th power. So we need to add these. So this is the part where I'm going to move to my notebook paper. All right, so we are adding 4.1 times 10 to the 5th power, and we're going to add that to 6.2 times 10 to the 6th power. All right, so remember, when we're adding, you must have the same exponent. So you have to make your exponents the same. So you can choose which one. You can choose one, you can make this one to 6, or you can make that one to 5. I am going to remind myself that if I move my decimal this way, I add my exponents. If I move my decimal this way, I'm going to subtract from my exponents, just so I have a reminder so I don't get myself all confused. All right, so I'm going to make this one a 5. So how do I make it a 5? I need to subtract 1. So if I subtract 1, that means I'm going to move my decimal one place to the right. So that now I have 62 times 10 to the 5th power. So now I can add these together. So we're going to rewrite using our associative property. We can regroup. So we're going to add those two numbers together. So we got 4.1 plus 62. And then we're going to look at our exponents. Well, since our powers of 10 exponents are the same, this is going to be to the power of 5. All right, now we just need to add 4.1 plus 62. All right, and so then if we do that, we get 66.1 times 10 to the 5th power. But we know this isn't in proper scientific notation. It looks like it, but it isn't all the way. All right, so we need to move our decimal to here. So we moved our decimal one place to the left. So if I look back at my notes, that means I'm going to add. So I need to add 1. And so then my final answer would be 6.61 times 10 to the 6th power. Right? Like I said, adding and subtracting are the most challenging. Multiplying and dividing, to me personally, are the easiest. But we're going to look at more. That's why we're doing these ones together. All right, so our next one says that we need to add or subtract, express our answer in scientific notation. All right, so here's our second question. So now we are going to look at these first, but oh, I so totally messed that up. Sorry, guys. This one is actually to the 6th power. I was like, oh, they made this one easy for us. Okay, so well, let's look. First thing we got to do then is make the exponents the same. All right, so if we look, we have 8 and we have 6. So if we move our exponent to the left, we add. If we move to the right, we subtract. So maybe easier to subtract 2 from this one to make it 6, or you can add 2 to this one to make it 8. It's completely up to you. So let's subtract 2 so I can make it 6. So remember, if I subtract, I'm moving my decimal to the right 2 times. So So now I have 570 times 10 to the, I'm sorry guys, just somebody was being really loud and taking my concentration. Okay, where were we? So 8 minus 2 gives us 6. All right, so now we've rewritten this one to look like that. This one we can keep the same. We didn't mess with it. So now that our powers of 10 are the same, we're good to go with that part. And now we just need to add our two factors. So we have 570 plus 3.2, and that's times 10 to the 6th power. All right, because that's why we're able to add them now that they have this the same. So if we add this together, we get 573.2 times 10 to the 6th power. So now, even though it appears to be in scientific notation, it's not in proper scientific notation. So we need to move the decimal to where it only has one non-zero digit in front. So we need to move the decimal two places to the left. Remember, if you move to the left, you add. So we now have 5.732, don't drop any of your numbers, times 10 to the 8th power. All right, now we're going to try a subtraction. Okay, I don't think we had a subtraction one. Or we did, we started off with it, how many more than, but we didn't have to move the exponents or change them by moving the decimal. All right, so first thing we got to do is make the exponents the same. All right, and so looking at these, they're negatives. All right, remember this one's closer to 0. So I can add 1 to this to get it to be -4. So if I add 1 to this, remember that means I'm moving my decimal to the left. So it means I'm going to move my decimal to the left 1 spot. So now I have 0.75 times 10 to the -4th power. And I'm going to subtract that from 1.3 times 10 to the -4th power because I didn't mess with the first one. I don't need to change anything. So now that we have the exponent and the powers the same, we just simply need to subtract those two numbers. So I'm saying 1.3 minus 0.75, and it's going to be times 10 to the -4th power. So those of you that hate decimals, if you want to use your calculator, you can. I won't be mad at you. Why this won't lighten up? There we go. So we have 1.3, and we are subtracting 0.75, and we get 0.55. So we have 0.55 times 10 to the -4th power. And so now we need to make it a proper scientific notation by moving our decimal behind the first non-zero number. Remember, we move to the right, we subtract. Right? So now we're making it back to that -5. Well, Ms. Gill, why are you doing that if you're just going to put it back? Well, think about if you wrote it out completely, your numbers would be different. So if we tried to subtract them like this, we would get something completely different. So that's why we have to actually make them exactly the same. All right, so now we have 0, or not 0. This is going to be a rough day for me, I can see. All right, 5.5 times 10 to the -5th power. So that would be our final answer right here. All right, so like I said, the adding and subtracting ones are the most challenging. You need help, please just let me know. I don't mind working with you on these. The next two are multiplying and dividing. Those to me are a lot easier. All right, so here's our next one. And since we are multiplying, we're using the product property, and you add the exponents. So I just put a little reminder over here off to the side. So now we're going to regroup our numbers. So how we're going to regroup them is we're going to multiply our first two factors together. So we're going to say 2.8 times 3.5. All right, and that's going to be multiplied to our second factors, which are our powers of 10. And so the whole reason we do this is because we know by the product of powers rule, we can add the exponents. All right, and so now we just simply multiply 2.8 times 3.5. So if we put that in the calculator, 2.8 times 3.5, we get 9.8. So we have 9.8 here times 10 to the 7 plus negative 3. So 7 plus negative 3 gives us a positive 4. So we end up with 9.8 times 10 to the 4th power. Now this one is in scientific notation. It has only one digit in front of the decimal. So this one we don't have to do anything else to it. It is fantastic just like that. See, this one was a lot easier. All right, so this one is a quotient property. So remember, we subtract our exponent. So I'm going to set this up like we did in lesson 2, where these two, I'm going to combine them together. And I'm just going to take 7.2 over 3 and times that to my powers of 10. So I have 10 to the 12th and 10 to the 5th. So I'm going to do that as 10 to the 12th over 10 to the 5th. And so then we're actually just going to work it out. So if you put in your calculator 7.2 and you divide by 3, you would get 2.4. And remember, when we're dividing, we subtract our exponents. So we end up with 2 to the 4th times 10 to the 7th power. And this one, we don't have to mess with either because it's already written in proper scientific notation. So we don't have to move the decimal, change the exponent, and all of that fun stuff that we have to do in the adding and subtracting. So I have a feeling you'll probably feel like I do. The multiplying and dividing ones are a lot easier than the adding and subtracting ones. They just take a little practice. So like I said, if you need more help, please reach out. Good luck on your assignment. I know you will do well.